Alright guys, I'm going to go ahead and get started. I need you to refresh my memory though. Were we on the January 2014 exam? Is that correct? Now I do remember doing number 39. I do remember doing the log equation. I think I remember doing this one. Did we do the parallelogram? Yes, we did the parallelogram. I believe I remember doing this one as well. Did we fully run through that one, or did we just set that one up? We just set this one up. So again, let's go ahead and pick this up from here then. What is our probability formula again? N combination R. The probability of success to the R power. And then the probability of failure to the N minus R power. So it says that he gets very little sunlight, that the probability that a plant will flower is only 0.28, a little bit more than a quarter. He planted 5 geraniums. He wants to determine the probability that at least 4 are going to flower. So how many did he plant?
Okay, I didn't want to turn off the lights.
Which ones did he, how many did he plant? 5. He planted 5. He wants to find the probability that at least how many will grow? At least 4. So we're starting off at 4 and going up to 5 or down to 0? Up to 5. So we're only going to have to run this formula twice. Once with 4, once with 5. We're trying to find the probability that they will flower. What is the probability that they will flower? So 0.28. So what power first? The 4th and then the 5th. So if the probability that it is going to flower is 0.28, then what's the probability that it's not going to flower? Why? They have to add up to 1. So if we take the difference of 1 and 0.28, we get 0.72. What power does this one have to be to first? The first power and then to the 0 power. Okay. So now we need to find the 2 individual probabilities, and what are we going to do with them? We're going to add them together, but the probabilities are going to be found in the calculator. So exactly as we have it written, starting with a parentheses, five into math, PRB for our probability. We want option number 3 for combination, so 5 combination 4. We want then 0.28 raised to the 4th, and then a 0.72 raised to the 1st. If we possibly can, we'd really like our probability expressed as a what? As a fraction. So let's see if we can fraction this off. We can't. We're going to leave that full value then, so we got 0.0221. Keep it going for me, please. 27. 616. Okay. And now it's really easy. All we got to do is hit second enter. And now we're going to go 5 combination 5. 0.28 to the 5th, and 0.72 to the 0. So we get 0.0017. Again, keep it going, please. 368. Okay, and now we're going to go ahead and we're going to add these 2 together. So to this, we're going to add the 0.022127616, and they want this rounded to the nearest what, folks? 1,000. How many decimal places is 1,000? 3 decimal places. 0.024. The 3 is going to go up to a 4. 0.024 is our probability then to the nearest 1,000 out of that one. Definitely the place that you want the probability question. Okay, a 4-pointer. If they just wanted exactly, it would be a 2-pointer, because you only have to run it once. But if they do an at least or at most, you've got to know the formula. You're going to have to find the probabilities, And then you're going to have to run it multiple times and add them together. So this is where you want your probability formula. Okay. Part 3, so it's a 4-point question. If you know your formula, you're golden. Okay. Questions on that one, folks? Very good. Did we even start this one? Did we finish it, though? We did. Okay, so we must have skipped then 37 to go up to this. This is what we're doing today, though, right? Okay. We've got to recognize this as being a what? It's a quadratic, right? It's quadratic. So what's the first thing we're going to do to it then? Set it equal to 0. This is one we were able to factor, right? Okay. And why did they ask for our answer in radian? Because our answers were nice numbers, weren't they? Okay. We didn't have to round values at all. They were 45s or 30s or 60s, and then we could easily convert them. How did we convert them? What did we multiply the degrees by to get the radian answers? Pi over 180 degrees. All right, so up into part 2s then. I like this question a lot. Did we do this one? We didn't have any of the part 2s then, right? None of the part 2s? Okay, very good. All right, so we've got this circle down here. We know that the radius is 12 centimeters. They want us to find the arc length x to the nearest tenth of a meter. Well, how do we find an arc length? What is that little formula we have? Easy to forget, though, but it has been on every single Regents exam. S, which represents our what? Arc length, is equal to r, which represents what? The radius of our circle times theta, which represents what? The central angle, but it's got to be in radian. It's got to be in radian form. Okay. So what do they have up here for us for the S? What is the arc length in this one? That's our x. We know that the radius is what? 12. But theta is given to us in degrees. We can't use it until we do what? We've got to convert it, right? We've got to convert it. So this Regents exam had 2 questions right within like 3 questions of each other where we had to do conversions from degrees to radians. What do we have to multiply this one by? Pi over 180. Okay? So let's go into our calculator, and this is a really good one as well because it's got degrees and minutes as well. So how do I enter in 83 degrees in 50 minutes? Second apps. 83 degrees, 50 second apps, minutes, 83 degrees in 50 minutes. And I'm going to multiply this by the quantity of pi over 180. So in radian, I get 1.463167669. Do I want to round this? I absolutely do not want to round this. So this is equal to 1.463 ... So now can I use that? Yep, and we're going to multiply it by 12. So that 1.463 ... We'll go into our calculator, we'll multiply that by 12. Okay. And now can we round? Yep, and what do they want us to round to? Nearest tenth. 17.6. X equals 17.6 centimeters. And that seems to make sense. Okay? If my angle is almost 1.5 radian, then that means I should be able to fit 1.5 radii up into here. Well, 1 radius would be what's our radius, folks? 12. And a half of that radius would be what? Well, 12 and 6 is 18. So it seems like we should be that. We weren't quite 1.5. That's what we've got. Okay. S equals our theta has been on every single Regents exam. You've just got to make sure that your theta is in radian form. You cannot use degrees when you're using this formula. You've got to convert it. All right, with 37 or 35? Okay, keep going up. Sequences. And specifically here they're giving me what kind of a sequence? Arithmetic. What does that mean? How do we get from term to term in an arithmetic sequence? And what do we call that amount? The common difference. We're adding or subtracting the same amount each time to get from term to term. As far as I'm concerned, this right here is the best sequence question they can ask, because we don't know the first term, nor do we know two consecutive terms. We know the fourth term is 19, and that the seventh term is 31. Well, what they want me to do is write a formula for a sub n. Okay, so do you remember what our explicit definition for an arithmetic sequence was? What do we have to start with? We've got to start with our first term, right? Okay. And then we add to that what? N minus 1 times of the common difference. Okay. If I want to find the second term, I only want to add one common difference, not two. So that's why we need the n minus 1 there. Well, the issue is I don't know a sub 1, nor do I know d. I know the fourth term and the seventh term. Well, by knowing the fourth term and the seventh term, can I figure out the two things that I need? Yes. Because how do I get from the fourth to the fifth term? We've got to add a d. How do I get from the fifth to the sixth? We've got to add a d. How do I get from the sixth to the seventh? I have to add a d. So write an equation here that involves 19, 31, and d. (19) plus 3 common differences has got to equal what? 31. So this allows me to solve for d then. How will we solve for d here? We're going to subtract 19 and divide it by 3. Okay. So 31 minus 19 is 12. 12 divided by 3 is 4. So I now know my common difference is 4. Well, if my common difference is 4, can I now work my way backwards to figure out what my first term is? Yeah. How do I undo adding 4? Well, we would subtract 4. Subtract 4. Subtract 4. So what's 19 minus 4? 15. Minus 4? 11. Minus 4? My first term is 7. Do I have all I need now? Absolutely. Any term in this sequence, a sub n, is going to be equal to 7 plus n minus 1 times of 4. And folks, do I need to go any farther than that? Will that give me full credit? It absolutely will. Can we simplify it if we want to? We absolutely can. What is 4 times n minus 1? 4n minus 4. Well, what's negative 4 plus 7? 4n plus 3. Either one of these is going to give you credit. You do not have to simplify down. They don't want a simplified formula. They just said provide a formula. They just said provide a formula. Could you also provide this? A sub 1 equals 7, and a sub n equals a sub n minus 1 plus 4. Could we also provide that? Absolutely. That's a recursive definition. How do I get a sub n? Well, I need to know the term before it, and then I add 4. Okay, either one of those would work. I guess either one of those three would work in this case. Which is the best one, though? The recursive or the explicit? the explicit. Okay? What would happen over here if I wanted to find the 15th term? What would we have to do? We've got to find all the first 14 terms. If I wanted to find the 15th term over here, just replace n with 15 and we've got it. Okay. All right with that one, folks? What is the definition of a geometric sequence? What is a sub n equal to for a geometric? Still starts with what? Still starts with a sub 1, but we're not adding, we are multiplying, and what are we multiplying by? The common ratio to the n minus 1 power. That's a geometric. Okay. Geometric is defined by multiplying or dividing by the same amount versus an arithmetic where we're adding or subtracting by the same amount. Okay. Are those? Now, what is on your formula sheet, though, with arithmetic and geometric sequences? They don't tell you the explicit definitions, but what is given to you on your formula sheet for sequences and or for arithmetic and geometric series? What do they provide you with? The sum formulas. Okay, if I wanted to find the sum of the first 10 terms of the sequence, we would use these two formulas. Okay? So those are provided, but not the explicit definitions. Okay? 33, just got to remember our powers of I for 33. So our powers of I, what we did was the clock. I to the second, I to the third, I to the fourth. We could have started at 0 as well. It doesn't make a difference. Anything to the first power is what, though? Itself. So I to the first is I. This is the big one. What was I squared? Negative 1. I cubed? Negative I. And then I to the fourth is going to be positive 1. Positive 1. And then 5th, 6th, 7th, 8th, 9th, 10th, 11th. You can even go backwards. 0. Negative 1, negative 2, negative 3, so on and so forth. You can go backwards around as well. Okay? So, there's nothing to do to the first term. That just remains 4x times I. But the second term is going to have 5y. What is I to the 8th going to be, folks? Five, 6, 7, 8. I to the 8th is 1 plus 6x. What's I to the third? Negative I. Plus 2y. What is I to the fourth? Positive 1 again. Okay, so over here I have a 4x I. 5y times 1 is just 5y. What's 6x times negative I going to be? Negative 6xi plus a 2y. So altogether, how many I do I have? Negative 2xi plus 7y. But how did they want my answer, though? A plus BI form. Am I in A plus BI form right here? No, I'm in BI plus A form here. All right, what do I have to do? Just flip them around, right? 7y minus 2xi. 7y minus 2xi. Folks, could I check this in my calculator? Could I store any number I want as x, any number I want as y, type in my original and type in this to see if they're the same? Absolutely, and you would be correct with that. Okay, you could type in any we want for x or y, and you would verify that that would be correct. Powers of I. Powers of I will definitely be on your Regents exam. I squared is negative 1, I cubed is negative I. Then we work our way around. All right, with 33. Cruising right along. 32. We've seen this one a couple times. What's the big key for absolute value equations or inequalities? There's two of them. There's two of them. How do we get the first one? We just simply drop the bars. Negative 4x plus 5 is less than 13. Now, folks, what has to be by itself before we can do anything? The absolute values have got to be by themselves. Okay? So if there was something being added to this over here, what would be the first thing I would have to do? Subtract it off. If there was something multiplied to it, we'd have to divide it out. We've got to make sure that the absolute value is isolated first. Then we can go through the two equations. What's the second one? Drop the bars. Do you ever change what's inside of the absolute value? No. So we drop the bars, and then what do we do with the other side? We negate the other side. Well, what happens when we negate inequalities? We've got to change the sign, right? We've got to change the sign. Okay. How do we undo adding 5? We're going to subtract 5 and get what? 8. We're then going to divide by negative 4. What's 8 divided by negative 4? Negative 2. What do we also have to do here then? Y divided by a negative. So x is greater than negative 2. Same thing over here. We're again going to subtract 5. But now negative 13 minus 5 is negative 18. And then again divide by negative 4. Now 4 does not go into 18, but negative by a negative is going to be a positive. And we can reduce. We'll get 9/2. And again, what do we have to do? We've got to switch the sign again. Okay? So, with inequalities, we always want to kind of sketch our solution set. So it's not just two answers. There's infinitely many solutions to this. The two numbers I'm concerned with are negative 2 and 9/2, which is 4.5. And we circle them up. Do I shade the circles in? No. When do we? Yet when it's equal to. Okay. And now, which way do I shade? Which way is greater than negative 2? To the right. And which way is less than 9/2? So where are we shading? We're shading in between them. Okay. This right here means that x is greater than negative 2, but at the same time less than 9/2. This is our and statement. X is greater than negative 2 and less than 9/2. Okay. If it's greater than, we would have shaded outside. Okay. Can I check this still as well, though? Yeah, I can pick a number out here and verify that it doesn't work. I can pick a number out here and verify that it doesn't work. And then I can pick a number right inside of negative 2 and verify that it works, and I'll pick another number right inside of 9/2 and verify that that works. Okay, but there really should be 4 places we check, one to the direct left and right of each one of your solutions, and make sure that it works. All right, with absolute value equation? I don't think I've ever seen one without an absolute value equation on it either in part 1 or part 2. Determine algebraically. So again, can we do it graphically? Yes, but we're only going to get at most what? 1 point. Okay. So determine algebraically just the x-coordinate of the points of intersection. Just the x-coordinate. Okay. So I've got to solve the system of equations. Remember how we generalized the system of equations? What was our process for the system of equations? The 5 what? The 5 S's. What was the first S? That's the second S. The second S is a substitution. The first S we have to solve. We've got to solve one of the two equations for either x or y. Now, is that already done for me? Yes, I already know that y is equal to what? Okay, so now, Brianne, we are going to substitute that x plus 3 in for y. So we get x. We always substitute with parentheses. We're going to replace that y with its equivalent, x plus 3. And still set it equal to what? 10. Okay. Well, once we do this, now we can do the third s, which is back to a solve. We can now solve for what? X. How do we do it? Okay, what do you get? X squared plus 3x. And since the 10 is already over here, folks, just for review, we're going to solve this by what? We're going to solve this by completing the square, just for review. We reviewed factoring today. We reviewed the quadratic formula today, but we didn't review the completing the square today. Now, ideally, is this a nice one for completing the square? No, we would like to have that value with x be what? Even. Okay? No big deal, though. We're going to come up with fractions. Who cares? We're going to do the calculations where? In calculator. Okay, so how do we complete this square then? We're going to take half of what? 3. Well, 3 is not an even number. We can't take half of it nicely. We're going to leave it as 3 halves. But then what do we have to do with it? We've got to square it. What's 3 times 3? 9. What's 2 times 2? So I just add 9/4 to one side? Got to do it to both sides, right? Well, why did we do that? Well, we did that to form a perfect square trinomial. When I factor this, tell me about my signs, please. They're the same. They're both positive. And what is the value that when I multiply it by itself, I get 9/4, and when I add it to itself, I'm going to get 3. 3 halves. Is it a no-brainer, though? Yeah, what is the value that comes right here? The half value. My half value was a positive 3 halves, so x plus 3 halves. Well, x plus 3 halves squared equals, well, if I'm going to add 10 to 9/4, we need to have a what? But you're going to do it where? In your calculator. 10 is 40/4. Because 40 divided by 4 is 10. Well, 40 plus 9 is 49/4, which you got where? In your calculator. All right? So let's solve it. How do we undo a square? Positive negative square root, right? X plus 3 halves equals a positive and a negative root 49/4, which is nice. Why? They're both perfect, right? They're both perfect. All right, how do I finish solving this for x? We've got to subtract 3 halves plus and minus 7 halves. All right, well, we can finish this up. What's negative 3 plus 7? 4. 4 divided by 2 is 2. What's negative 3 minus 7? Negative 10 divided by 2? Negative 5. Have we done what we were asked to do? They wanted us just to solve for the what? The x-coordinates. Have we done that? Yes. Just for a good review, though, how do I finish this off? So I've done the solve, I've subbed, I've solved. Now what am I doing? I'm substituting these numbers back into the other one. So when x equals 2, y equals 2 plus 3, which is 5. When x equals negative 5, y equals negative 5 plus 3, which is, my answers need to be provided as a what, though? as a coordinate. Where do they intersect at? Two 5 and -5, -2. Folks, would you have lost any credit by doing this extra work over here? No, absolutely would have not lost any extra any credit. But did you do a lot more than was necessary? Yes. Okay, so if you would have done something wrong over there, would you have lost credit? If you circled that as your answer and you did something wrong over there, you absolutely did. You absolutely did. Okay? So make sure if you're going to do extra work that it's correct. Okay? Answer what they wanted. They just wanted the x coordinates. My x coordinates, bang, done. All right with that one? The 5 S's. Solve, sub, solve, sub, solve. And then check. Questions on that one at all? 29, IQR, the interquartile range. All right, interquartile range. Is there a computation behind finding the interquartile range? Yes. What is the IQR equal to? Upper quartile minus the lower quartile. Well, where are we going to go to find these? You are. But seeing that these numbers, are they already in order? Let's do it by hand and in the calculator as well. Okay? How do I find quartiles? First off, I guess tell me this. What do quartiles do to a set of data? Split it into 4 equal sections, right? Well, before I can split it into 4 equal sections, I've got to split it into 2. What do I first need to find? I first need to find the median, right? Okay, so 1 on each end, 2 on each end, 3 on each end, 4 on each end, 5 on each end, 6 on each end. What's the median? 8. The median is right there at 8. Okay, so our median is 8. Okay, so I have 1, 2, 3, 4, 5, 6 below, 1, 2, 3, 4, 5, 6 above. Well, now what do I do to find the lower quartile? Find the median of the lower half, right? Well, what would the median of the lower half be? Right here at 3.5. That would be our Q1. What would be our upper quartile? Right here in between the 10 and the 11 at 10.5. Okay. So, Q3, 10.5, minus Q1, 3.5. I have an interquartile range of 7. What percent of my data lies within these 7 scores? 50%. Your quartiles break you into quarters. 25% lies here, 25% lies here, 25% lies here, 25% lies here. So 50% of my data lies within 7 scores. What's the range of the data? What's that? 12, yes, 12. 14 minus 2 is 12. So 100% of my data lies within 12 scores, but 50% lies within just those 7 scores. That's the interquartile range. How do we do this on the calculator, folks? How do we get the calculator to tell us these values exactly? We're going to go into Stat. And in Stat, we're going to go to Edit. Yep. And what are we going to put into L1? 2, 2, 3, 4, 6, 7, 9, 1, 2 10s, an 11, a 12, and then my 14. What's very important that we do? 14, 12, 11, 10, 10, 9, 7, 6, 4, 3, 2, 2. Are we good? Okay. Now what do we do? Back into Stat. Over to Calculate. The one variable statistics on L1. One variable statistics on L1. So what does X bar represent? The mean, yep. What's sigma X represent? That's the sum of all of my scores. What's capital S of X? That's the sample, not the variation. Standard deviation. That's the sample standard deviation. What's this one? The standard deviation. What does N tell me? How many scores we had. What's min X? Lowest score. What's Q1? First quartile. MED? Median. Q3? Upper quartile. Max X? Good. Okay, now Carolyn, you brought up variance. We need the variance before we can calculate the what? And what do we do to the variance to get the standard deviation? We take the square root of it. So folks, by knowing the standard deviation, can I also figure out what the variance is? Yes. What would I do to this number right here to find the variance? We would square it. So really, out of all the measures of central tendency and the measures of dispersion we talked about, what's the only one that I can't figure out from the calculator? What are the three measures of central tendency? Mean, median, mode. And then for the measures of dispersion, we've got the what? IQR. Before we'd have the IQR, we would have the normal what? Range, and then the variance and the standard deviation. What's the only one the calculator can't tell me? The mode. Do we need a calculator to tell us which score occurs the most? Hopefully not. Hopefully not. Okay, so the calculator tells us everything we need to know for stats. All right, with the IQR? This is a nice part, too. Very nice part, too. Area of a rhombus. What's a rhombus? If I don't know, I'm kind of hung up. What's a rhombus? 4 equal sides, so it's a square? Can be, but is it generally? No, it's the square that's been hit. Okay, so it tips off, but all 4 sides are the same. Here's my rhombus. Okay. I know all the sides measure 6, 6, 6, 6. And an angle of 50 degrees. Well, let's make that obviously the acute one here at 50 degrees. So where else is 50 degrees? Yep, opposite of that is 50 degrees. Do I know what these two angles would be then as well? They would be 130, right? Well, how do we find the area of a rhombus? What's that? Yeah. What's the height? I don't either. How are we going to find the area of the rhombus? What's that? I still can't hear you. Find the area of 2 triangles. What do we know about those 2 triangles? They're congruent, right? So they're going to have the same what? They're going to have the same areas. How do we find the area of a triangle? One half any 2 sides times the sine of the angle in between them. Now, Olivia, you were kind of stressing a little too much there. Is that a formula you had to memorize? No! Where do you find it? Reference sheet. It's a formula given to us on the reference sheet. A and B represent what? 2 sides. And then this capital C has got to be the angle that's in between them. Do we know 2 sides? We absolutely do. They're both 6. And then what is the angle that's in between them? 50 degrees. Now, could we have also made this diagonal go that way, and then instead of using the 50 degree, use the 130 degree as well? Absolutely. Wouldn't make a difference at all. Would not make a difference. Now, this is finding the area of what? The triangle. So after we find this, we're going to have to do what to it? We're going to have to multiply it by 2. After we find this, we're going to have to multiply it by 2. Or, right at the very beginning, we could do what? Just get rid of the 1/2. Yep, just get rid of the 1/2. And then just do AB sine C. It's going to be the same thing. 6 by 6 is 36. Half of 36 is 18. So I just need 18 sine 50. 18 sine 50. Folks, I don't know what mode my calculator's in, so what am I going to do? I'm going to put the degree symbol in. It's just as easy as checking my mode. 18 sine 50 gives me 13.788, so on and so forth, and then we're going to multiply it by 2. To the nearest tenth of a square foot, 27.6. Square feet. Here we got 13 points, what was it, 7887. So again, if we would have just taken off the 1/2 at the beginning, then we wouldn't have had to multiply by 2, and then we would have gone right to that 27.6. Any parallelogram is the same. Okay. Straightforward. They gave us everything we needed. 2 points right off the Regents reference sheet. All right with that one? Last one in part 2, 28. Nice. Identities. How many trig functions do we have? 6. There's our 3 basic ones, the SOHCAHTOA ones, and then there's our 3 reciprocal ones. Okay? So this right here is the basic identities that we just discussed earlier on in the week. We know that secant theta is really what? 1 over cosine theta. Sine theta, I'm not going to do anything to sine theta, but I am going to turn it into a fraction and make it sine theta over 1. Cotangent theta, I know 2 things for cotangent, but we said we weren't going to use 1. We want cosine theta over sine theta. Cotangent is cosine theta over sine theta. And we're trying to show that this is equal to what? 1. Yeah, we're trying to show this is equal to 1. Well, folks, what do we do with fractions before we multiply them? This cosine theta is going to cancel that cosine theta. They become 1s. This sine theta is going to cancel that sine theta. They become 1s. What do we get? 1 equals 1. We have proven that this is an identity. Folks, no matter what angle you pick for theta, multiplying secant of that angle to the sine of that angle and the cotangent of that angle is always going to give us 1, no matter what your angle is. All right, with our part 2s, 3s, and 4s? All right, let's see if we can get a couple of the part 1s. I'm going to bounce right up to the top. Nice, easy way to start the Regents exam. What is the common difference? What do I have to add to 2a to get 4a? 2a. What do I have to add to 1 to get 4? So what do I have to add to 2a plus 1 to get 4a plus 4? 2a plus 3. Choice number 1. Folks, can I put any number I want in for a? And instead of having kind of an algebraic sequence, get a straightforward numeric sequence? Absolutely. Absolutely. I could have done this one in the calculator. Okay. So number 2 is straightforward calculator? It absolutely is. What do you do? Yeah, a weird prime, a 2-digit prime. Type it in, type your answers in. Any questions on how you would do that on the calculator? Okay, so let's refresh ourselves on how we do this by hands. Okay. What do negative exponents do? They reciprocate, right? They reciprocate. What is the reciprocal of 3x squared over 1? 1 over 3x squared. What's being squared? Just the x. What answer do we have? Choice number 1. Choice number 1. There's a second way to look at this as well, folks. What's being raised to the negative first? The 3 is being raised to the negative first, and x squared is being raised to the negative first. So what's the reciprocal of 3? 1/3. What's the reciprocal of x squared? 1 over x squared. Do we still get 1 over 3x squared? We absolutely do. Any questions on that either way? Multiple choice or by hand? Very good. Good question, an important concept, and I like the format of how they ask this. I like this notation better than the other notation. What do I have to do first? I've got to evaluate h at negative 8. Why do I have to do that one first? Doesn't come first. G comes first. Inside of parentheses, right? Okay, folks, I want you to first tell me before we do this, what is the other notation they could have used here? The circle. So we're going to do a circle of negative 8. Now, how do we read that circle? Follows. What follows what? G follows H or H follows G? G follows H. It's the same thing there. So we need to evaluate H at negative 8. What does that mean right there, folks? How do I evaluate H at negative 8? Substitute in negative 8. 1/2 negative 8 minus 2. What's half of negative 8? Minus 2 more? Negative 6. And now I'm going into G with what? Negative 6, which is 1/2 of negative 6 plus 8. What's half of negative 6? Plus 8? Positive 5. So what is G parentheses H of negative 8 equal to? 5, choice 3. If you'll notice, if you did the composition backwards, if you did the G first, I bet that answer is there as well. Okay? If you do G at negative 8, half of negative 8 is negative 4, plus 8 is 4. Half of 4 is 2. 2 minus 2 is 2. It's not. Wow, that's surprising. Okay, so that should be an automatic clue in there for you that, ooh, I did it the wrong way. Okay, you always do the inside first and work your way out with no matter what notation, inside out. It's number 4, a complete calculator one. It absolutely is. You take 1 and divide it by the quantity 7 minus radical 11. You find your decimal answer and then you type in the other 4 answers. But what's the concept with this one, folks? If this is a part 2, how do I divide 1 by 7 minus radical 11? I've got to multiply by the what? Very important word. You will probably see it on your Regents exam. Conjugate. What is the conjugate? 7 plus radical 11 to the top and the bottom. Well, the top is easy. 1 times anything is always what? Itself. 7 plus radical 11. What's nice about multiplying conjugates? The inner and outer parts cancel, right? So all we need to multiply is first and last. So what's 7 times 7? 49. The inner and the outer are going to cancel each other out because they're the same things, but one's positive and one's negative. And then lasts. What's a negative times a positive? A negative. Radical 11 times radical 11 is radical 121. But we know that better as 11. So what is 49 minus 11? 38. 7 plus radical 11 over 38. Choice number 1. I like this. I think this is a great question, but I don't like it in part 1 because it can be done completely in the calculator. I like this one in part 2. It's a pretty simple concept. It's just a FOIL. We just got to understand that I've got to multiply by the conjugate. I'd rather see this one in part 2 than in part 1 because it's a very simple one. All right, with 4? 5? Can this be done in the calculator as well? Absolutely. What are you going to do? Store for A, B, and C. Are you going to try to do this all at once, though? No. You're going to evaluate the top, and you'll evaluate the top and store it probably as N for numerator. You'll evaluate the bottom. You'll probably store that as D for, and then you'll divide numerator by and get an answer. And then you'll start typing in the answers down here and get those as well. So again, this is another great question, but I'd really prefer it in part 2. A over 1 plus B over C. Not worried about the denominator. I'm going to try to do this just top. I can't add these. Why? Well, what would it be? I need a factor of C over here. Okay. So what do I get then when I add them? A times C plus B over C. D over 1 minus B over C. Why can't I subtract them? Same thing. What is that common denominator again? So DC over C. What do I get when I subtract these then? DC minus B over C. Do I now have one fraction over one fraction? We don't divide fractions though. What do? We multiply by the reciprocal. And what's going to happen? The factors of C cancel out. I get AC plus B over DC minus B. Which is which choice? Three. Choice 3. What did they try to do to get 4? They tried to say, well, these B's are the same, they cancel out, don't they? Absolutely not. Why? They're attached. They're attached. Can you see why people would circle it, though? Just don't fall into that trap. Okay. Statistics type question. School cafeteria has 5 different lunch periods. The cafeteria staff wants to find out which items on the menu are most popular. So they give every student in the first period lunch a list of questions to answer in order to collect data. Which type of study is this? Is this an observation? No, what's an observation? You just sit back and watch what happens and take notes. What's a controlled experiment? You're testing something, so you give one group this placebo, and you don't give it to this other group, and you see what happens. That's a controlled experiment. What's a population survey? Everyone in all the 5 periods get the survey. What's a sample survey? Just some of them. So is this which one? This is a sample survey. Why? Only 1 out of the 5 periods were surveyed. So this is a sample survey versus a population survey. Okay? 1-to-1 and on to. What does 1-to-1 mean? For every x, there's 1y. For 1y, there's... Okay? Is this one 1-to-1? No, it is not. Why? 2 goes back to 2 different spots. Not 1-to-1. Is 3 1-to-1? No, why not? Yeah, 2 goes back to 2 spots again, and R goes to 2 spots. Number 2, 1-to-1. Yes, 2 is 1-to-1. Is 4 1-to-1? Yes, 4 is 1-to-1. Which one is on to? What does on to mean? All the values in Y are being used. This one's not being used. That is not onto. Every Y value needs to be used for onto. 1-to-1 Every x, there's a y. Every y, there's one x. On 2, every y element is being used. This one is not on 2. Okay. What does 1-to-1 mean? Graphically, it does what? What does it pass? Vertical and horizontal. Yep, it passes vertical and horizontal and means that the function has a what? An inverse function. Everything has an inverse, but only 1-to-1 functions have an inverse function, which means that that inverse also passes the vertical line tests. Okay? Basic quadratic, is it 1-to-1? No. No, it fails the horizontal line test. That's not 1-to-1. A linear function, 1-to-1? Exponential function, 1-to-1? Yes, absolutely. Log function, 1-to-1? Yes, absolutely. A lot of the functions we discussed this year are 1-to-1. The quadratics are not. Okay? Moving on to 8. We'll end with 8. Max solves a quadratic equation by completing the square. He shows a correct step. X plus 2 squared equals -9. What are the solutions? I like asking the completing the square question in part 1, but I don't like him doing this. I think you should have to determine how do we get to this. The best question, I think, is what gets added to the side. So they'll give you this. X squared plus 4x equals -9. I think the best question that they can ask about completing the square is, what needs to get added to both sides? I think that's the best question. This is all right, but they're just asking us to solve an equation. How do we undo a square? Okay, so x is going to equal -2 plus and minus the square root of -9. So -2 plus and minus 3i. Where does the I come from? The negative under the radical. The 3 comes from the 9. The I comes from there. So -2 plus and minus 3i would be the solution to this one. Folks, can this be done in the calculator, though? So do you need to know anything about completing the square to actually do this problem? No. You type in your solutions, you find out which one works. Do you have to type them both in? No. Because they are what's of each other? Conjugates. If one works, the other's got to work. Okay? We can do this one as well. Arrangements. Does order matter with an arrangement? Yes. This is a permutation or combination? Permutation. But it's a permutation with what? Repetition. What is that formula for permutations with repetition? R factorial. What does the n represent? We have 11 letters. So 11 factorial. What's being repeated? How many? 2 m's, 2 a's, 2 t's. Choice 2 or choice 4? Which one? Choice 4. We've got to multiply them. We've got to multiply them, not adding them. If we were adding them, they would be somehow representative of the formula that they're adding in the bottom. They're not. They're being multiplied. Choice number 4 is what we've got on that one. Good with that one, folks? We should easily be able to finish up the rest of the multiple choice in next session. Now, folks, remember, when's the next one? Tuesday. But will we be having class Tuesday? No. Okay, so don't forget, we've got reviews Tuesday and Thursday. We're not going to be in school. Well, you'll probably be in school. Do you guys have Regents on Tuesday? Okay. History? Yep. Okay. So just remember, Tuesday and Thursday evening, there is still review, but I won't be there to remind you. Okay. We still got 2 days of class with Friday and Monday. I am going to offer times during the day that you can come in. I just got to sit down and see the Regents schedule and see who's taking what when and see what times would be able to accommodate most people. I want to try to keep it consistent, though. I don't want to change times, so Monday it's this time, but then Wednesday it's this time. I want to try to keep it consistent all the way through Tuesday, Wednesday, and Thursday, on times you can come in. Now, for those times to come in, though, it's going to be a time for you to come in with questions for me, or you just want to sit down and take a Regents exam. We're not going to do something like this. I'm not going to put on a dog and pony show. So if you want to come in, you want to come in to work on a practice Regents and ask questions as you go, or you have specific questions for me already that you would like me to answer. Okay? We're not going to do something group like this. Okay? But I will let you know at the very latest Monday the times that you could come in those, but we still have Tuesday and Thursday. I am going to make a stipulation on Thursday night, though. You can't come Thursday night unless you've come before. Okay? Which you guys are all welcome then to come Thursday night because you've all come before. If you haven't come before, is it too late Thursday night to come? Yes. You're getting nothing out of it. You're getting nothing but the teacher with the steam coming out of his ears because you haven't come yet. Okay, so there will be a stipulation on Thursday night. You cannot come Thursday night unless you've been here previously. Okay? Questions, guys? Thanks for coming. Have a great night.